Hi dear students, welcome to Geeta's classes. In this class, we are going to do some problems on how to find out the Laplace transform of functions divided by t. So before that, you have to be thorough with the basic formulas, that is the Laplace transform of the basic functions, elementary functions. Like first see the definition. L of f of t is integral 0 to infinity e power minus st f of t dt, and L of any constant is that constant divided by s, and L of e power at means 1 by s minus a, L of e power minus at is 1 by s plus a, L of cos at is s by s squared plus a squared. Please remember here c and s, okay, and s for sign we will not get s, it will be constant a by s squared plus a squared. And cos h at is s by s squared minus a squared. L of sin h at is a by s squared minus a squared. And L of t power n is n factorial by s power n plus 1 when n is an integer. Otherwise, if it is a fraction, then you can use gamma of n plus 1 divided by s power n plus 1, provided we can reduce that function to gamma of 1 by 2 or gamma of 1. Okay. And the first shifting theorem says that always remember, whenever you get f bar of s, remember it is nothing but L of f of t. The Laplace transform of f of t is f bar of s. Okay. And if the function is multiplied by e power at, without e power at, you have to find out the Laplace transform of f of t, and s should be replaced by s minus a. That is why we have written in the f bar of s is replaced by s minus a. Therefore, f bar of s minus a. Similarly, if it is multiplied by e power minus at, s should be replaced by s plus a. And if the function is multiplied by t power n, if you want to find out the Laplace transform of t power n into f of t, without t power n, you find out the Laplace transform of f of t. That is L of f of t is f bar of s. That's why we have written f bar of s. And differentiate n times with respect to s. Please remember, when we are finding the Laplace transform, L of f of t you are finding, right? It is integral 0 to infinity e power minus st f of t dt. So after integrating with respect to t, you are substituting the limits for t. So after that you will get a function of s only. That's why we are writing it as f bar of s. Okay, please remember this. L of f of t will be a function of s. We are transforming from t to s. So after finding the Laplace transform, you will be getting a function of s. That's why we are differentiating with respect to s n times. And minus 1 per n should be multiplied with that. Please remember, for multiplication we are differentiating. For division we have to integrate. Okay. So L of f of t by t is equal to integral s to infinity f bar of s ds. What is f bar of s? L of f of t. Okay. And so means what? Without t you find the Laplace transform and integrate from s to infinity. Okay. If it is t squared, f of t by t squared, twice, double integral, integral s to infinity, f bar of s ds. Okay. So now let us do the problems. Find L of 1 minus e power t divided by t. So this is equal to, if it is divided by t, what you have to do? You have to find out without t, divided by t, that is 1 by L of 1 minus e power t. Whatever is there in the numerator, you will find the Laplace transform of that, then integrate from s to infinity. See, here sometimes we will feel like writing e power t. No, dt, it is not dt, because e power at, sometimes we will make that mistake, dt, it is not dt. Actually we are finding the Laplace transform, therefore it will become a function of s, so you have to write ds. Okay, it is not dt. With respect to s you have to integrate. That is integral s to infinity L of 1 by linearity property e power t. You can separate them ds. That is equal to integral s to infinity. What is L of 1? 1 by s minus. For this only you have to be thorough with the Laplace transform of elementary functions. 1 by L of e power plus t. E power t is 1 by s minus 1. If it is e power minus st, s plus 1. So into ds. Okay. That is equal to, now when you integrate, what will you get? Log s minus log of s minus 1 from s to infinity. that is equal to, you can write log of s by s minus 1 from s to infinity. Like this, when you have to, actually we have integrated with respect to which variable? S. So for s you have to apply the upper limit and the lower limit. When you apply upper limit, log of infinity, okay. So it is, we cannot find out log of infinity. So what you have to do is, try to express that 1 minus e power t by t is equal to, try to express that in terms of 1 by s, okay. So s by s minus 1 you have, so you take this s outside, in the denominator s is there, no, you take this s outside so that it will get cancelled. So s into 1 minus 1 by s, so from s to infinity. So here s and s will get cancelled. So log of 1 by 1 minus 1 by s from s to infinity. So this is equal to log 1 by, if you want 1 by 1 minus infinity you can write. So this will become 0, this will become log 1, okay. So minus, in the place of s, s only. So 1 by 1 minus 1 by s, right. So log of 1 is 0. So 0 minus log of, again you take the LCM. So this will become s minus 1 by s. So this s will become, it will come to the numerator, okay. So this is s by s minus 1. So this can be written as log of s by s minus 1 the whole power minus 1. So it will become log of s minus 1 by s. This is minus 1. So this is equal to log of s minus 1 by s, log of s. Actually from here itself, if you are thorough, you can write log s minus log of s minus 1 from s to infinity is just, it will get reversed. So how it is getting reversed you should know, okay. So you should understand the concept. So it is log of s minus 1 by log s is our answer. Next problem, log of cos at minus log of cos bt divided by t. So when it is divided by t, you have to find out log of cos at. Without that function, you have to find out the Laplace transform log of cos bt. Without t, you find the Laplace transform and integrate from s to infinity into ds. This is equal to log of cos at is what? S by s squared plus a squared minus s by s squared plus b squared, and integrate from s to infinity into ds. Now you have the generally you will feel like writing tan inverse of s. It is not tan inverse of s. You have s in the numerator. If it is a constant, then you can write tan inverse of s by a, okay. So now s is there in the numerator. So means what? If you have 2s, that is the differential of the denominator is there in the numerator, then we can write log of this, okay, log of the denominator. So 2 is missing, so I am going to multiply and divide by 2. That is 1 by 2 into log of s squared plus a squared minus log of s squared plus b squared. If the differentiation of the denominator is there in the numerator, you can write log of denominator, okay, integral s to infinity. So this is equal to, we can write it as one more step, 1 by 2 into log of s squared plus a squared by s squared plus b squared from s to infinity. Okay, so this is equal to, now I have to take s squared outside, s squared into s squared plus a squared you have, so s squared I am taking it outside, so it will become 1 plus a squared by s squared divided by s squared into 1 plus b squared by s squared from s to infinity. So s squared and s squared will get cancelled. So this is equal to 1 by 2 into log of 1 by 1. So log of 1 minus log of 1 plus a squared by s squared by 1 plus b squared by s squared. So this is equal to 1 by 2 into 0 minus. So minus of log of. Now you take LCM. So s squared plus a squared by s squared plus b squared, which is equal to 1 by 2 into log of s squared plus b squared. That minus we can take it to the power. So it will become power minus 1. So s squared plus b squared by s squared plus a squared. The whole power 1 by 2. You can bring this 1 by 2 to the power. So a squared plus b squared by a squared plus a squared. Or you can say the whole power 1 by 2. Or you can say log of under root a squared plus b squared by a squared plus a squared also you can write. Or you can write in this, you can stop in this step also. The whole power 1 by 2. You can stop like this also. Next question. Log of sin t by t. So what is the definition? What is the procedure? Divided by t means without that t, you find the Laplace transform of the numerator and integrate from s to infinity with respect to s. So log of s integral s to infinity. What is L of sin t? 1 by sin a t means a by s squared plus a squared. Here a is equal to 1. So 1 by s squared plus 1 squared into ds, which is equal to integral s to infinity. Directly I can integrate. It is 1 by s squared plus 1 is nothing but tan inverse of s from s to infinity. That is tan inverse of infinity minus tan inverse of s. What is tan inverse of infinity? Pi by 2 minus tan inverse of s. Pi by 2 minus tan inverse of can be written, tan inverse of s can be written as cot inverse of s. That is the formula. Okay. So L of sin t by t is cot inverse of s. Now we have one more question, that is e power minus t into sin t by t. So please remember, if it is multiplied by e power at or e power minus at, you have to recollect that. You have to apply the first shifting theorem. Okay. So here e power minus t is multiplied. Therefore, without e power minus t, you find out the Laplace transform and replace s by s plus 1. So just now we have found out L of sin t as cot inverse of s, right? So L of this is equal to L of sin t by t you can find out, in which s should be replaced by s plus 1. What is L of sin t by t? Just now we have found it to be cot inverse of s, in which s should be replaced by s plus 1. That is cot inverse of s plus 1 is the answer. So all these combinations only you will be getting in the exam. Okay. So you can take this as a practice problem. L of e power minus at minus e power minus bt divided by t. So without t, you find the Laplace transform of e power minus at and e power minus bt, and using this the same method, log, you will be getting log of and apply the infinity by taking s outside. The answer will be log of s plus b by s plus a. So if you want, if you are actually for doing these problems, you should be thorough with the differentiation and integration. Okay. So if you want any basic classes for differentiation and integration, the introduction classes, if you want basic function, how to find out the differentiation, how to find out the integration, the basic classes if you want, please mention, comment in the comment section so that I'll upload that. Okay. And please give a like for this class and please share it with your friends so that it will be useful for them also. Thank you so much for watching.